Hello, Professor. Good morning. Hope you are doing well today. We are from Group 14. Today, we are going to give the presentation on predicting the power consumption in manufacturing industry using the data science models. First, let me introduce myself. I'm Sandeep Kumar Kota. Currently, I'm pursuing my master's in computer science at Wichita State University. In this project, I'm going to explain about the introduction of the energy consumption. So before going that, I will ask my teammates to give a small introduction.
Hello, Professor. This is Shanmukha Venkata Shyamkrishna Perla, and I have worked on the background research on this project.
Hello, Professor. I am Shanmukha Reddy, pursuing my master's in Wichita State University. I have worked on research questions and hypotheses.
Good morning, Professor. I'm Sandeep Sagar Panjala. I mostly worked on methodology and methodology mostly. Yeah. Thanks.
I'm Akshara. I'm currently pursuing Masters in Computer Science. I worked on the findings.
Myself, Gopi Krishna. I worked on recommendations and use case.
Good morning, Professor. I am Pawan Kumar Reddy Mudiala, and I am currently pursuing Masters in Computer Science at Wichita State University. And in this project, I have worked on use cases, implementations, and references.
So let me come to the introduction of the project. Can you change the next slide? Okay, so as we all know that energy is one of the largest expenses in the manufacturing industry. So especially the industries like steel, coal, petroleum industries use the large amount of energy to manufacture their products. So as per the statistics given in the year of 2021, the energy consumed by the manufacturing sector is increased by 4% in 2021 compared to 2020. So predicting the total energy consumption in the manufacturing industry has become the major concern to the manufacturing unit, which really affecting the cost of the product. The companies that predict the energy consumption will have the better advantage than companies who don't, which help the companies to set cost of the manufactured product. Next slide.
Coming to the background research, like we can see nowadays, the population has been increasing day by day, and the energy consumption on different sectors has been increased. So, for instance, we can see in the past, like COVID-19, there is a huge supply of medication as well as the production of masks. This requires a lot more energy, and this might help. This might be affecting the environment as well, and also to predict the energy consumption, so we can use the data mining models that can use it to analyze the energy consumption, such as iron making and steel making process. These models can identify energy intensive process and help to optimize the energy consumption by adjusting the parameters like such as temperature, pressure, and oxygen. So the next slide.
Coming to the research questions, the main thing we need to find the relationship between consumption depending on the day and the cost of the manufacturing product and the budget plan. And coming to the hypothesis, we need to increase the energy of consumptions and manufacturing process such as machinery and source of energy of day by day will increase manufacturing of the product, and budget plan and makes the manufacturing until will be expensive. Next slide.
Coming to the methodology, first let me introduce the data set. If you observe the data set, we have a couple of columns, a bunch of columns over here, starting from the day to the load type. We have taken complete 2021 data, start from the January 1 to December 31st. And on the second column, we have a usage in kilowatts per hour, and we also have a lagging power, leading power, lagging power factor and leading power factor, and as well as the carbon dioxide included. And NSM comes as a number of seconds from midnight, or we can also call it as a power number of seconds of power has been used. And we have a week status, like on is it a weekend or weekday, and we have a day of week like Monday, Tuesday, Wednesday. And lastly, we have a load type. Load type is like light load, medium load, or the maximum load. Entirely we have a 35,441 rows after data cleaning and all, with the size is 2.6 MB. Initially, we started our data with the data cleaning. First, we renamed some of the columns which are not appropriate. So we renamed with the proper names, and then we identified some of the columns with missing values, especially usage in kilowatts. That is the primary value of in our data set. So that's why we removed them. We removed those records, and then we identified some of the outliers. We also removed them. Then we proceeded with the feature engineering. First, we started with the encoding. We always wanted to encode the load type, which is a categorical column. So we encoded with the one hot encoding feature engineering. We encoded load type, and then since we have a date column in our data sets, we also wanted to do the date extraction. So we will get a year, month, day, even time, the difference of time, all those things. So we can utilize for visualization, and we can also utilize for the model training and all. Then coming to the data visualization, firstly, we wanted to show you the most energy consumption by date. So the first picture goes there, and then we wanted to show like how much maximum load, medium load, or the light load which was consumed, like the entire year, how much the maximum load has been recorded, how much the medium load has been recorded, and how much light load has been recorded. And coming to the heat map, this is a correlation. We have used a Pearson correlationship, and the heat maps looks very somewhat like positive, strong. We got a strong positive correlation, and as well as somewhat strong negative correlations also. Yeah, that is our heat map. And coming to the statistical analysis, since we have a somewhat more than two dependency variables, we wanted to use a linear regression models. So that's why we have used the regression models. We started with the linear regression models. We have taken some training data and the test data. We applied the training data on the linear regression model, and surprisingly, we got very good score over here, which is 98.41. Since we got very good score, we don't want to stop there, and we wanted to continue with the other regression models which we have. So next we applied a ridge regression model, and that is also we got very good score, which is 96.883. And lastly, we applied a lasso regression model. Comparatively not very good score with the previous two, but we got 91.08. We got a 91.08 in the last regression model. Yeah.
Coming to the findings, to predict the power consumption in steel industry, we used the regression models, linear regression, ridge regression, and lasso regression model to test the data set. We found that linear regression gives 98% result, ridge regression gives 96% result, and lasso regression gives 91% result. Based on the analysis of various regression models, it is evident that linear regression model is an ideal model for predicting the energy consumption in steel industry due to its high accuracy of 98%. And when compared with the predicted value with the actual value, the outcome is as close to the original value. Next slide.
Recommendations. After conducting a comprehensive analysis of data, we have determined that achieving precise load types predictions based on the numerical inputs, prediction derived from overly complex datasets may require additional classification. The present data set, there remains the possibility of further research into load prediction. Use case. One of the use case of this model is the companies can successfully invest vast amount of money and time into maintenance and proper functioning of their machines and devices. These companies can do their best to order the customer needs and desire with the manufacturing product. Next.
Yeah, and coming to references, these all are several references and citations we are taken from Google and Wikipedia, and this will be much helpful for further research. Next slide, please. And thank you, Professor, for giving us this wonderful opportunity.
Sagar, your voice is not audible.
Yeah, thank you, Professor, for giving this wonderful opportunity to us to explain our project in detail. Yeah, thank you.
Thank you so much, Professor.